In Chapter 3, we're kind of switching gears, and we're no longer working on solving things or getting x by itself. Instead, we're going to talk about how these linear functions that we've dealt with look like on a graph. So we're going to start today with identifying linear equations, identifying intercepts, and zeros. Zeros we'll talk more about in the next section. But by the end of this lesson, you should be able to graph linear equations by using intercepts and tables. So make sure you can do both. So what is a linear equation? It is something that forms a line when we graph it. So we're going to focus on standard form for a while in this class, and standard form is ax plus by equals c. If an equation is a linear equation, it can be written in this form with an x value and a y value, and then equaling a constant or a number. So that's what we're going to practice first. Determine if each equation is a linear equation and write it in standard form. So remember, standard form looks like ax plus by equals c, so that's what we're going for. So when I look at this first equation, the y is over on the left side, but the x isn't. So let's move it over. So I'm going to just add 3x to both sides. So I'm going to write the x's first because that's what standard form looks like. And now double check, is it in that form? ax plus by equals c. If it is, you should be able to pick out the a, the b, which would be 1 in this case, and the c. And because it is, yes, it is a linear equation, it would make a line when we graph it, and this is standard form. So let's try the next one. This already has the x and the y on this side, and it equals a number. But something weird is here. If I try to pick out my a and my c, I can do that. But I don't really have a b here. Instead, I have an x again, which can't happen. So in this case, this is not a linear equation. And that's because it can't be written as y equals ax plus, ax plus by equals c. So now let's get into the graphs. Linear equation can be represented on a coordinate graph. So hopefully you remember this from your other math classes. You have your x-axis and your y-axis. Remember, this is your origin. It's at 0, 0. If you go this way, you are in positive x land. And if you go this way, you're in negative x land. If you go up, you're in positive y's. And if you go down, you're in negative y's. So when we take a look at points here, when you have points, they're coordinates. So you always go x's first, then y's. So here, your x would be positive and your y would be positive. Here, your x would be negative and your y would be positive. Here, your x is negative, y is also negative. And then finally, here, x is positive, y is negative. So hopefully you remember that from previous classes, because today all we're focusing on is intercepts. So an x-intercept is where it crosses the x-axis. So right here is our x-intercept for this equation, because it crosses the x value, or the x-axis at -4. And then your y-intercept is where it crosses the y-axis. So here's my y-axis, and it crosses right here at 2. Now remember, when something crosses the x-axis, that means that the y equals 0 here, because we're not going up or down any. And when something crosses the y-axis, that x equals 0, because we're not moving left or right any. So when I give you something like the x-intercept is 2, you should be able to turn that into a point, because you know that y has to equal 0 when it crosses the x-axis at 2. Or if I tell you that the y-intercept is 6, you should be able to make a point because you know x has to be 0 there. The graph of a linear equation has at most one x-intercept and one y-intercept. If it's an equation that is this line, then it has all of these points. Or if it's an equation that's this line, then it has all of those points. But for the most part, you're either going to have one x-intercept and one y-intercept, or one of each. So let's say we have a story. Swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in the pool and the time and hours that the pool has been draining by the x-intercepts and the y-intercepts of the graph. Let's find the x-intercept first. So we can look at this two different ways. We could look at the actual table, or we could look at the graph. Chances are looking at the graph is a little easier, but remember, when something crosses the y-axis, the x-axis, that means y equals 0. So when I look here, I have two spots that I can see it. The x-intercept is at 14, 0. And then if we go and switch gears and look for the y-intercept, remember that that means the x equals 0. So I have my table right here, and then I have my graph. And it's a good thing we have the table, because chances are if we didn't, we wouldn't know this exact value. So my y-intercept is at 0, 10,080. And then it asks us to describe what the intercepts mean in this situation. So let's think about this. X is time, y is volume. So when we have time equals 14, volume equals 0, that means it takes 14 minutes to empty the pool. Has no more water in it. Where this one over here is kind of the opposite. Time at this point is 0, and the volume is this giant number. So that means when we started with 10,080 gallons of water. So let's graph some on our own without a story. And we're going to graph these using intercepts. You only need 2 points to make a line. Only need 2 points. So we can find 2 points to make a line by using the intercepts. And something that's really awesome here is if we go to find the x-intercept, remember that means that y equals 0. So what I'm going to do with this equation is instead of writing y here, I'm going to replace it with 0. Because if y equals 0, that means it's crossing the x-axis. And then all I have to do is solve this. But when you plug in 0, something magical happens. This kind of disappears because 4 times 0 is just 0, and you're left with a really easy equation to solve. Now remember, an intercept is a point. It is not a number, so do not leave x equals 4. Turn that into an equation where a point where x equals 4 and y equals 0. So there's 1 point. Now we just need one more in order to connect our dots. So if I want to find the y-intercept, remember that means x equals 0. And when I write out my equation, instead of writing x, I'm going to plug in 0. So same thing happens, that goes away, and I'm left with another really easy equation to solve. So I get y equals 4. So here is my point. This should be 8. I don't know what's going on today. This is definitely 8 when you divide this. So our point should be 1, 2, 3, 4, 5, 6, 7, 8, somewhere out here. Now this one's 4, but it's on the y-axis. So it should be here. So once we have these two things, all we need to do is connect the dots, and we have a graph of this equation. Now, one thing I want you guys to make sure that you do is lines go on forever and ever and ever. So don't draw little dinky lines on your graph. Draw them huge, make them take up the whole graph, and also make sure that they have arrows on the end, signifying that they go on forever and ever. Now, the other way you can graph things is by making a table. I would suggest that you just use the intercepts, but let's try one like this. This one's a little tricky because it doesn't have an x and a y in it. It only has an x. So if I were to make a table of this, usually we plug stuff in for x, but this equation tells me that x always has to equal 3, that it can't equal anything else. And it doesn't matter what y is. I could make these up all day long because x is always 3. So when I go to graph this, if x is always 3, that means I'm going to go over 3, up 1, over 3, up 2, over 3, up 3, up 10. I could go down -8, down -42. But whatever I'm graphing, x always has to equal 3. And for all of these points here, x equals 3. It does not matter what my y value is. If I wanted to graph this one using a table, we'd approach it the exact same way. Plug some stuff in for x, maybe pick a couple negative numbers, 0, a positive number. Doesn't really matter what you pick because you're just going to plug it in and see what you get out for y. So if I plug in -2 for x and solve for y, I get -4 minus y equals 2. I can add 4 to both sides. And then divide by -1, so I get -6 here. So there's a point, back 2, down 1, 2, 3, 4, 5, 6. If I plug in 0, I get -2. If I plug in 3, that gives me 6 minus y equals 2. So subtract 6 from both sides, divide by -1, I get 4. And now I have some points here. All I got to do is connect them. So we're going to focus a lot more on the intercepts than we are making a table, but it's equally as important that you can plug stuff into a table and get things out. So I know this says using the x and y intercepts, but for this one I want you to use a table. And graph it here. This one, use intercepts. And graph it there. Make sure you write down any questions you have and we can go over them together in class. Enjoy your night.